Welcome back to All This Math. This is Professor Parker, and I really like these problems. I always did, ever since I was in middle school when I first started rocking out with these, right? Dividing rational expressions. Dividing rational expressions. I think the reason that I like these types of problems so much, and the multiplying ones, right? The dividing rational expressions and multiplying rational expressions is because they start out like looking so complex, but then when you learn how to factor, if you know how to factor, right? And you break them down, break the expressions down into factors. If you got like an expression in the numerator or denominator that you could factor, you break it down and then you start to get the slicing and dicing and canceling stuff out, cross canceling, vertically canceling. And then it's like, you end up with like such a simple answer. And it's like, wow, like this problem started out looking real complex and then you really just broke it down and you end up with like something real small, you know? I think that's why I always like these types of problems. So here, as I said, we're dividing rational expressions. First off, what does it mean? What is rational? What is a rational expression? A rational expression, let's just say it's a fraction. It's a fraction, right? An expression that can be represented as a fraction, such as 8k over the quantity of 24k squared minus 40k, or 1 over the quantity 15k minus 25. Let me point something out, though, because I know a lot of people like to do this. This 8 and this 24, you can't divide those. This 8 and this 40, well, negative 40, you can't divide those. So you can't, basically what I'm saying is, you can't change this to a 1 and change this to a 3. You can't reduce that. You can't treat this like it's just 8k over 24k squared. Just like you can't do k divided by k squared and cross that k out and leave this as a k. You can't do that. You know why? Because these two terms are a binomial. That's a binomial. Those terms are connected, right? So you can't just go in there with like one term and then get to like, reducing parts of this binomial. You can't do that, right? These terms ride together. They stuck together. So that means you can't get to reducing anything or dividing anything until you factor. Now, once you factor and then you have a standalone expression, then you can start reducing stuff if you want to. You know what I mean? But I wanted to point that out because that's a very common error that I've seen a lot over my years of teaching. And if it's not pointed out to you, you might think that it makes sense. Because, it seems like, well, I see an 8 and I see a 24. I know 8 over 24 is 1/3. So why can't I change that 8 to a 1 and change that 24 to a 3? I know that 8 over 40 is 1/5. So why can't I change that 8 to a 1 and change that 40 to a 5? The reason you can't do it is because you can't go inside of an expression, whether it's a binomial or a trinomial, and just start reducing parts. You can't reduce parts of a binomial or parts of a trinomial. You can't do that. All right. So anyway, I don't even know how to start this, right? Because it's a division problem. So when we divide, we do the keep, change, flip thing that you're probably familiar with. It doesn't matter, like, if you're talking about doing 1/3 divided by 3/5, you keep, change, flip. When you get to algebra and you got to divide rational expressions, keep, change, flip don't go away. You still apply the same principles that you did with regular fractions, with fractions that look like this. You still do. All right. So one thing I got to do, I know I got to keep, change, flip because I want to convert this into a multiplication problem. All right. That's one thing I got to do. Another thing I got to do is I got to factor. I know I got to factor this expression, this binomial, and factor this binomial. Now, which I do first really don't matter. It really don't matter. It's a matter of preference. I think what I'm going to do is I like to flip it first. That's what I like to do. I like to flip it first. No real reason. That's just probably how I started doing it years ago. Maybe I had a teacher that showed us how to do that in class, and I just, latched on to that method or that procedure. So what's going to happen is we're going to do keep, change, flip, meaning, in case you're not familiar with what keep, change, flip is, it's a method for dividing fractions where we keep the first fraction in the same exact form. Then we change, we're going from left to right, right? Then we change the division sign into a multiplication sign. Hence the word change, we change. And then we flip the second fraction, or meaning we take the reciprocal of the second fraction. meaning that the denominator becomes the numerator and the numerator becomes the denominator. Think of it like bunk beds. Like, so whoever sleeps on the top bunk, they go to the bottom bunk. Whoever sleeps on the bottom bunk, they go up to the top bunk, right? That's flipped. That's a reciprocal. So this is what it's going to look like after we do it. So we're going to have, we keep that, we keep it the same. So we got 8K is over 24K squared minus 40K. Change that to a multiplication sign. You can use a dot. I wouldn't use an X because at this level, you might be dealing with variables that are X. And then we flip this. This is going to be 15K minus 25 over 1. Now we got a multiplication problem. All right, so now we got a multiplication problem. So what we're going to do is, now it's time to factor. I know I can factor this because this has a GCF that I could pull out, right? 24K squared minus 40K. First thing you do is you look at your coefficients. I got a 24 and a negative 40. The GCF of 24 and negative 40, the greatest number that they are both divisible by is 8. It's 8. Now you want to pick the greatest number, especially when you're doing a problem like this, because if you pick just a random common factor and not the greatest, you're going to have to do the steps over and over again. You got to keep factoring and keep factoring and keep factoring. Listen, you want to just be one and done. Find the greatest common factor. Don't use 2 or use 4 or nothing like that. Use the greatest common factor, which is 8. So out of the coefficients, the greatest common factor is 8. Keep that in mind. Then out of the variables, k squared and k, the greatest common factor is k. Because you take the variable with the smallest exponent. So you're going to have 8k. That's your GCF. So let's do this. We're going to rewrite this fraction. The numerator don't change. We're not messing with the numerator, right? So we got 8k. And then we write for our denominator, put our GCF outside. And then in the parentheses, we divide everything by the GCF. We divide everything by the GCF. So this 24k squared gets divided by 8k. So 24 divided by 8 is 3. So I'm going to put a 3 right here. K squared divided by k is k. Because of the division rule for exponents, you subtract the exponents. This 2 subtracts or is subtracted by this invisible 1. 2 minus 1 is 1. So you're left with k to the first power. That's the division rule for exponents. I got videos on that if you need to brush up on that, all right, on this channel. And make sure you already subscribe to the channel, All This Math. Subscribe to the Instagram also because we got content there too. Now, divide the negative 40k by 8k. What's negative 40 divided by 8? Negative 5. So put your minus 5 there. Then k divided by k is 1. So it would be negative 5 times 1, which is just negative 5. So now this is completely factored into this. Then I come over here, put my multiplication sign, put my fraction bar. 15k minus 25. I need a GCF. What is the greatest common factor of the coefficients? 15 and 25. 15 and 25. Greatest common factor is 5. It's 5. 5 is the largest number that both 15 and 25 are divisible by. So I write 5 as my GCF. Then I put a set of parentheses, open parentheses. Now, I make them that wide so I can fit 2 terms in there. Why 2 terms? Because I started out with 2 terms, 15k and negative 25. If I start out with 2 terms, I'm going to end up with 2 terms in the parentheses. How do I get the terms in the parentheses? By doing division. I find a GCF, then I divide by the GCF. So I do 15k divided by 5. I do 15 divided by 5. That gives me 3. And then it's a k. There's no k term here. That's cool. That means I just include the k with my quotient. I just keep the k with my quotient. So 15 divided by 5 gives me 3. And then I keep the k right there. And then negative 25 divided by 5 gives me minus 5, right? And it's over 1. All right? Now that's the fun part. That's why I told you in the beginning. I always like these types of problems because now it's when you get the slicing and dicing, canceling stuff out. So now what I'm doing is I'm looking for things that are the same or that can be reduced or divided by each other. So automatically or immediately, I should say, I see 8k and 8k. Boom, cross them out. They turn into 1s because they're the same thing. That's like saying 8k divided by 8k. Anytime you divide something by the same thing, it's always 1. All right. Then we can also do it diagonally, right? We can go vertically in the same fraction, or we can go diagonally. Why does diagonally work? Diagonally works because if I was to combine these two fractions into one fraction, then it would just be vertical. It would be like 8k over 8k. But right now, the 3k minus 5 is here, and the other 3k minus 5 is over there. They're diagonal right now because these are separated into two separate fractions. But think about it. Think about it for a minute. If I was to combine these two into one fraction, then it would just be 3k minus 5 on top, 3k minus 5 on the bottom. But they're just not combined. But that's why we can what we call cross cancel. We can cross cancel, right? So I got 3k minus 5 down here, 3k minus 5 up here, boom, boom. They turn into ones. What's left? Anything else? Nothing left. So now I do my multiplication. Now you do your multiplication. You're going to do 1 times 5 times 1. That's 5. Look at your denominators. 1 times 1 times 1. That's 1. We got 5 over 1. Let's reduce that. Equals 5. So you see what I'm saying? Like, I like these problems. I always like these problems, right? And because look at what we started with. Now, if you don't know how to do these problems, then this might look intimidating. It might look intimidating, but if you know how to factor, right? If you know how to do keep, change, flip, and also before we even get into all that, if you're confident that you can do the problem and you can figure it out, that's a key element as well. Because a lot of people lose because they're just not confident that they can do math. And once you convince yourself and you got all that negative self-talk going on, you convince yourself that you can't do math, you ain't never going to be able to do math. Straight like that. You're not. And you got people that's like for year after year after year, they told themselves all through middle school, all through high school, and even if they went to college and took some math classes, they told themselves, yo, I can't do this. I can't do this. It's too hard. It's too much. I don't get it. It don't make sense. What's the point of this? Why I got to do this? They kept telling themselves that. So you don't even get to the point, you don't even open yourself up to be willing to accept like, yo, somebody's really trying to break this down and show it to you in a way that makes sense. You so caught up and stuck on that programming that you had for the last 15, 20 years or whatever. And now you might have kids now. And now you passing that on to them. So that's another reason why I created this channel, is for parents to get down and learn this stuff so they can help their own children. So y'all can help your children with their homework, because your children got to do this now. So dig it. Try your best to move past that negative self-talk, right? And just believe and say, well, what if I can understand this? What if I can? All this time in the past, I thought I couldn't, but what if I can? What if I can learn this? What if it's not as difficult as I always thought it was? Or maybe, what if I just needed a different explanation? Or what if I just needed somebody else to explain it to me? What if, right? Now, you start out with all of this. If you know how to factor, you know how to divide fractions, apply the rules, boom, boom, boom. You know how to reduce fractions, and you end up with 5. That's the final answer. All right? Now, use this video as a guide, and now go practice. You got to practice, because it's not enough just to watch a video. You got to go practice. All right? So you go get some practice, and I'll catch y'all on the next video. Peace.